Now we're going to do hypertrophy. We're going to start with left ventricular hypertrophy criteria. That's LVH. And there are a bunch of different criteria. I basically just remembered this one and this one for EKG boards, and that was enough for me. And then I included this one because this is supposed to be the most accurate diagnostically for predicting the presence of LVH. I don't find that necessarily to be true in my clinical practice, but that's what the science says. So let's do the first one here, AVL greater than 11 millimeters. You can look down here at this EKG. In this tracing, we're looking at AVL, and we can see that the height of the QRS is more than 11 millimeters. It's like something like 14. And I find that really easy to remember because AVL, L looks like a 1, and then there's LVH, so there are lots of things that look like L's, and that's all you need to remember, AVL greater than 11. So that's a simple criterion and almost impossible to forget. All right, let's look at the second criterion, the largest S wave in V1 or V2. So that's the downstroke, the S wave, plus the largest R wave in V5 or V6, that's this guy, it's the R wave. If those two things added together are greater than 35 millimeters. Let's take a look at this one here. All right, so the largest, there's a typo here. This should be S, and this should be R. Sorry about that. So the largest S wave in V2, here's the S wave, and that's maybe 23 millimeters, plus the largest R wave in V5 or V6, and the V5 one's bigger, goes up to there, and that one's maybe 28 millimeters. Those two things added together are 51 millimeters, and that's clearly greater than 35 millimeters, so this is an LVH ECG. Let's look at the last criterion here, which is the R in AVL plus the S in V3, greater than 28 millimeters in males, greater than 20 millimeters in females. So let's look down here. The R in AVL, we got about 14 millimeters. And then the S wave in V3, 5, 10, 15, 20, 22. So that's 36 millimeters, and that's greater than 28. So we have LVH by that criterion. There are ST and T wave changes expected with LVH. So we expect to see a downsloping ST depression in the lateral leads of 1 millimeter or less, and then with associated T wave inversions. So we're looking at the lateral leads down here. There's a downsloping ST segment and then a T wave inversion. And you can see that in all the lateral leads. And then also, there's up to 3 millimeters of ST elevation in leads V1 and V2, typically with high voltage. So, for example, here in V2, there's really big S wave, and then there's ST elevation here, 3 millimeters or so. So that's expected with LVH. On to atrial hypertrophy, which would be the same thing as atrial enlargement. So over here in the atria, the sinus node is up here. It's at the top right side of the right atrium. And the best lead to look at the atria is usually lead 2, and then also V1 is very good. And that's because lead 2 shows 60 degrees, and that's pretty much the whole direction that the atria depolarize. It starts up here, and then the depolarization goes in this direction, which is the same direction as lead 2. So lead 2 tends to have the highest magnitude P waves. And V1 sits right over the right atrium. So the atria depolarize towards V1 because the sinus node's in the back of the right atrium. And that's also a really good lead for looking at atrial depolarization. First, let's take a look at left atrial hypertrophy. So in lead 2, the P wave is greater than 2.5 millimeters wide. You can see that here. That's about 3. And in V1, the criterion is the P wave is greater than 1 millimeter tall and greater than 1 millimeter wide. So more or less. It's hard to read that type of thing, so you're pretty much being a little qualitative there. But if it looks like a pretty big negative deflection in the P wave in V1, then that implies left atrial enlargement. The reason it's negative in lead V1 for left atrial enlargement is because if the left atrium is really big, then that portion of the depolarization is occurring in a direction away from lead V1, which sits about there. So also that happens in the second part of the P wave. This doesn't show it that great, but this P wave, it starts out a little bit positive, then it goes negative. And the positive part is what's happening in the right atrium. And then the negative part's what's happening in the left atrium. So that's why in lead V1, P waves usually look kind of like this, where it's positive at first, and then it's negative, because first the right atrium depolarizes, because that's where the sinus node is, and then the left atrium depolarizes. Anyway, this is the second criterion for left atrial hypertrophy. All right, right atrial hypertrophy, tall P wave in lead 2, greater than 2.5 millimeters. And then the criterion for V1 is greater than 1.5 millimeter tall, and that's what you got here. And this shows the same thing where the right atrium goes and then the left atrium goes. It's hard to see it, but it's there. Let's look at a couple of examples. Left atrial enlargement. It's another typo. It should be over here in lead V1. And this little negative portion of the P wave in V1 is greater than a millimeter wide and greater than a millimeter tall. So that's left atrial enlargement. It doesn't show it here in lead 2. It's probably less than 2.5 millimeters wide, but it's an either or criterion situation. So if you have one of the two, then that counts. Right atrial enlargement example, P waves greater than 2.5 millimeters tall.